All right. So I would like to give you some very quick, intuitive introduction to the doubly linked list. Many of the points over here are already covered by the bullet points, but I would like to just elaborate more on the visualization. Let's take a look before we dive into the Java. Right, so let's now go over point by point. Number one, doubly linked list is simply just a chain of bidirectionally connected nodes rather than single direction. It will not be bidirectional. And each node, doubly linked node, contains three things. So we got a data objects, and also we got a next node, and also we got a previous node. So exactly like this, right? If you think about the doubly linked node over here, it's going to be something like this. So this will be how the object will look like over here. You get, so that's the node that we're going to discuss later, right? It's going to be an generic class, node of E, and then we actually got data, and also we got the next, and also we got with the previous. So that's how you visualize the objects for every doubly linked node over here, right? And the data might be pointing to some objects somewhere. And also the next is going to point to another nodes. And the previous will be pointing to just another nodes previously, right? So that's a doubly linked node. And you will definitely see me visualize the chain of doubly linked nodes later when we design the algorithm. And it's really important to also understand this point over here. A doubly linked list is also a singly linked list, but not vice versa, because a singly linked list is simply not a doubly linked list, because the singly linked list lack the notion about the previous reference for individual nodes. So that's why it's simply you cannot say vice versa, right? Not vice versa. Yeah, not vice versa, because number one and number two, right? Two things. One is about the previous reference. And the second thing is about the header and also trailer, which I will try to visualize again. Header, and also trailer. In the case of the singly linked list, you got head and tail, right? It's different. And so here, many methods implemented the same way, because each doubly linked node simply got the next reference. So if you simply keep the same implementation that you actually did from the singly linked list and simply copy and paste for doubly linked list, it would be okay, because everything will still compile, because you still got the next reference. That's okay, right? So this point is also very important for convenience. So don't think that if you actually want to adapt yourself into doubly linked list, you're going to redefine all your methods. That's not the case, right? Many of them will simply be okay, because the next reference is actually available for every doubly linked node. On the other hand, you want to really notice this. Some method implemented more efficiently, right? Let me just give you some idea. That's actually the case for example, remove last. And I'll get to this point in just a moment, right? And also, we talk about accessing a node in the list. It will still be linear, unfortunately, right? So whenever we talk about linked list, either singly linked or doubly linked, if you want to simply get the relative positioning by getting to somewhere in the middle of the list, the worst case running time will still be linear, right? There's no way around. If you really want the constant amount of time for accessing, you have to choose the array, right? Absolute indexing, which will be the case for the array, right? And the chain may actually grow or shrink dynamically, pretty much by setting the references, which we'll see when we get to the precise implementation. But you already got very good idea from the case of singly linked list. And I want to also speak about these dedicated header versus trailer node, right? So there's something I want to visualize right away, right? I want to give you two cases. So case number one. So case number one will be empty list. How do you visualize an empty doubly linked list? Empty doubly linked list. How do we visualize that? In that case, you simply don't have any meaningful data stored, because you simply have no node, but you still got a header and trailer. So it works like this. The header is actually going to point to a doubly linked node, which will be this particular node, which I just visualized above. Right? So this will be the node of E, and then we got the data, and also we got the next, and also we got the previous. All right, let's take a look. Let me just copy this because the trailer is going to have the same structure. Okay. Okay, and we got the header, and also we got a trailer. Okay, the trailer is pointing to this, right? So we got header and trailer. They're dedicated. They always exist, even for empty list. What about their the references for their attribute fields? Let's take a look. In the case of the data, they both store simply null. And data over here also stored to null. Right? What about the next and also previous? In this case, one thing to know that's very important is the previous reference for the header node is always null. And the next reference for the trailer is also always null. Always. Because before the header, there's simply no other node. And also after the trailer, there's also no other node. So that's why they are really the beginning, also the end. Right? That's what a sentinel really means, right? From the dictionary. And let's now talk about and the next and also previous for the header. So the next reference for the header will definitely be pointing to the trailer. And symmetrically, the previous reference for the trailer will be pointing to the header. Right? So that's something you can see. Right? That's how you visualize an empty doubly linked list. And of course, if you also have the size attributes that's also stored in the doubly linked list class, the size would just be 0. Right, so that's case number 1. And for case number 2, I would like to show to you how the doubly linked list will look like when there are actually more than one nodes that exist in the list. Meaning that there will be, rather than just the header and trailer, we do have some nodes in between. That's something we would like to see. And let me just make some room quickly so that I can draw the second case also on the same page. Let's now do that quickly. Okay, I'm just going to resize it over here. Okay, I think it's still visible when you download the notes. That's good. All right, and just this one here, I'm just going to move it over here. Alrighty, let's talk about case number 2. Right, I'm going to draw a little bit smaller. Okay, so for case number 2, I'm going to use a different way of drawing, in which case I don't really have to show each individual node objects in detail. What I can do is I can just try to draw the one with only 3 compartments over here. I think that'll be easier. But whichever way you prefer, it's kind of up to you, right? They got pros and cons for each one of them. And for case number 1, let me use purple, right? So case number 2. So case number 2, all right? So we still have our 2 sentinels or guards, which will be the header and trailer, right? So the header, which will be pointing to, let's say over here, and each one of them has 3 compartments. And let me just copy the template for this. We're going to need that for a few, right? Why don't we say we got a list of size 1, 2. I might just be able to, okay, let's say size 2, right? That's good enough, all right? And let me just be more explicit about, let me just use the color to really show to you more explicitly what I really meant to do. So let's say these are simply the actual node that will store meaningful data. That's a purple one, okay? So we still got our header and trailer. So header and trailer over here, right? And don't forget, for the header, the previous reference is going to be null. And the data is going to be null. And it will point to the first nodes in the chain, right? And also for the trailer, its next node, its next reference is going to be null. The next reference is going to be null. And also its data will also be null, right? And its previous is actually going to point to the last node over here, right? So that's a previous one, right? And let's also set up the references for the 2 nodes. This will be the first node, and this will be the second node. And by the way, what's the size currently? The size, of course, is going to be 2 rather than 4. So we only count those nodes that will actually store the meaningful data. So that means we don't really count. We exclude the counting for the header and also trailer. They are there just to make things easier for us, as we'll see when we get to the Java coding. Let's say the very first node over here, let's say the data is simply stored maybe some name. For example, Alan. And the second node over here also stores some data, maybe Mark. All right. And what about the next and previous? Let's say I use the maybe pink over here. So the next of the first node, of course, will be pointing to the second node. And also the next of the last node is going to point to the trailer. All right, so that's the pink references you can see. And let me also use pink. For the first node, its previous node should be the header. And also for the second node, its previous node is also the first node, right? You can see. That's kind of how you set up the references. Let me just write down some facts over here for you, right? So when you think about the next and previous, right? We talk about header, trailer. So we talk about header, we talk about trailer, and we talk about the first node, and we talk about the second node, right? Let me use a table over here. And we talk about the next reference, and also we talk about the previous reference. Let's now try to use this table to summarize what we have learned so far. Okay. Okay. Right. In the case of the header, its next will just be the first node. Its previous will be null. Agree? And for the trailer, its next will be null. And its previous will be the last node. Okay, let me just make sure over here, I really meant to say the last node, even though in this case, the second node is just the last node. Right? You can see this is the first node, and this is the last node over here. Right, let's now also talk about the other two. What would be the next node for this first node? In this case, it will be the last node, right? It's really the second node, but I would just say last. I'm talking about this case specifically, right? The next node for the first node is the second node, which at the same time is the last node, right? And also, what would be the previous node for the first node? It would be the header. So this will be the header. And for the last node over here, what will be its last node? The last node over here, its next node will be just the trailer. And for this last node over here, what will be its previous node? In this case, it will be just the first node. In this case, right? Of course, if you actually got more than 2 nodes in the list, then the answer for this one and also this one here might be a little bit different. But for now, it's okay. Right? It will be the first node. So what you really want to pay attention to are these fields over here. So you want to pay attention to this one, this one, this one, this one, and also this one, and this one over here, right? I think this table also gives you a very good idea about the general structure for the doubly linked node, right? Right, so that's about the visualization, and I would like to talk about this point as the last point I would like to address over here. Some method implemented more efficiently. Let's talk about the remove last specifically over here. If I want to remove last, think about what you had to do in the case of singly linked list. Somehow you have to go from the head of the singly linked list, and you want to traverse all the way to the second last node. In this case, in order for you to remove the last node, right? And that will take, in general, linear time. But now, since you got a previous node, you got a previous reference for every doubly linked node. In this case, how can you get to the second last node? All you can do is you can say the last node, which is over here. What will be the last node? It will be trailer.previous. This will be the last node. And how do you get to the second last node in order to remove the last node? You would say trailer.getPrevious. Only 2 reference lookups, and that's it. So that's why it's constant time, right? Right. Let me write it down. So it's really important for you to know that the second last node is simply the trailer dot previous dot previous. And of course, here I'm not being very accurate. If you really want to write a Java code, you may just want to say trailer that get previous and get previous for the public accessors, right? But for now, conceptually, it's okay. So trailer dot get previous, this will give you the second last node. And that way, you can actually remove the last node with just constant amount of time, right? Over here, you can see over here, this will be the previous, and over here, this will be the previous over here. After these two lookup, you can actually get to the second last node. The second last node, which will take only constant amount of time to really get access to in the case of doubly linked list. But in the case of singly linked list, getting to the second last node in general will be a linear time operation, as we explained before. Right, I think that's enough about the intuitive introduction to the doubly linked list. And with such intuition, I'd like to give you some quick exercises to do, just mentally. I want you to go back to the notes for your singly linked list, and remember we implemented quite many basic methods in the singly linked list. And also I assigned to you also quite a good number of exercises about singly linked list operation. I want you to go over every one of them and think about the following. Given that we have already introduced the previous reference for the doubly linked node, and are we able to now to improve the performance of the method that only was able to use the next reference in the case of singly linked list, right? That's something I would like you to think about. And you can think about for each one of them, if you can actually improve the performance using the previous reference in the doubly linked node, you can think about how you might do it. If you cannot, justify why not, right? So that's something I would like you to think about. Well, at least you know that for the remove last method, you are able to actually do it by using the previous reference over here, right? And I just make one more annotation. So this case over here is really for non-empty list. That we spoke about, right? So intuitively, you should really distinguish between empty lists and also non-empty lists and how they actually look like in the case of the doubly linked node. All right, that's about it. And let's now move on to Java implementations.